In this video, we're going to run through several of the WEKA classifiers using the WEKA Explorer tool available from the WEKA GUI chooser. First, we need to load our file that we had built, the spy.arf file. And there it is with our 4 attributes. The result is actually the next day price here, and it's what we'll be classifying on. Let's step through the classifiers from the chooser tree that is provided to us. A lot of these classifiers aren't available to us because the data that we produce is not quite what they can work with. So most of these probably can't work with numeric data, which is what we have. So the first one we get is closure classifier, and we simply start it. We're doing a 10-fold cross-validation test, and we come up with our correlation coefficient, which is pretty close to 0, and a mean absolute error of approximately 42. Correlation coefficient of 0 is not good at all, because that pretty much means the data is random. The results are random. And the mean absolute error means that the results are off by about 42. Next up, we go to the functions. DLP classifier we won't run it. It takes more than 5 minutes to run, and actually it doesn't produce any information whatsoever. But briefly, like all of the classifiers available through the GUI, you can just right-click on it, hit the properties, and you can change any of the properties available that are used by the classifier. And then the more gives you some descriptions and capabilities, provide information about the attributes that it accepts. Again, this DL4J Mlp classifier won't be used. It takes too long and does not produce any data. So next up is Gaussian Process. Again, a very slow classifier. This one takes over an hour to run, and it produces results that are not very useful. Not as good as what you'll see in the next 3 or 4. Linear regression. Let's start it. Very fast. We get a correlation coefficient close to 1, which is really, really impressive. A mean absolute error of about 0.77. That's a pretty good swing there. And what's interesting about linear regression model, it gives us kind of like this equation here, what it uses to produce its results. So it says it multiplies the current price by about 0.95, multiplies MA fast by about 0.034, MA slow by 0.016, and then a constant of 0.013. And you could probably take this equation and apply it to the data that's in the ARF file. Up next, Mlp Regressor. Pretty fast. Excellent correlation coefficient. Absolute error, not as good as the linear regressor, which was at about 0.7. This is about 0.9, but still pretty good. Up next is multi-layer Perceptron. This one, another slow one, and the results aren't very good, along with its cousin, multi-layer Perceptron CS. RBF network. Start it up. It's pretty quick. correlation coefficient, not as good, 0.86, and the mean absolute error, pretty high there at 24. RBF regressor. This is slow, and it produces some pretty good results. Oops. Not very fast, but let's take a look here, and we get, there's the last fold, and there we go. Excellent correlation coefficient, but its mean absolute error is even higher than a linear regression and MLP regression. Simple linear regression produces some interesting results. Very, very fast. Very close to 1 there on the correlation coefficient. Mean absolute error, 0.77. And if we look at its equation, all it does, it takes the current price and adds 0.01 to it for its predictions. SMO reorg. Another slow one here. Slow compared to the simple linear regression and the linear regression functions. It's still building the data model. As it steps through, let's take a look at the weights while it's doing its testing. It multiplies the current price by 0.94, MA fast by 0.08, MA slow 0.02, and a constant of 0.002, and we're still waiting for it to build the first fold. This is a long process. Okay, so what's it, 2:26? It started at 20 after the hour, so that took over 6 minutes, maybe 7 minutes to run. As we can see here, the correlation coefficient are pretty darn good. Almost 1. And the mean absolute error of 0.77, not too bad either. Up next, we go into some of the nearest neighbor, another excellent correlation coefficient. Mean absolute error, not so good. Not as good as SMO reg and linear regression. Up next, its little cousin here, which does of IBK's cousin IBK-LG. Start it, and results are fast. Mean absolute error just slightly better. We're going to skip K-star and LLW because both of these produce not so great results. So we'll go down to, and we're going to skip the metas, which are just a combination of classifiers. We want to use the pure classifier situation if we can. And we want to go to decision tree. Skip the scripts. Now we're going to go to conjective rule. Conjective rule is very fast, but the results are not so great. Decision tree. Fast, results not so great. M5 rules. Pretty good. Correlation coefficient, close to 1. Mean absolute error, not too bad at 0.77. And again, we get pretty much the same numbers that the linear regression classifier produced. Zero R we've already seen, it's not so great, and we did that in the first video. We're going to skip scripting and the sklearns, it's not available to us, and down to the last node here of trees. CDT, I've run this and it doesn't produce anything, results it pretty much hangs, so we're going to skip that one. Decision stump, very fast. Correlation coefficient and the mean absolute error, not nearly as good as the others that we've seen. Extra tree. Pretty fast. Excellent coefficient, but the absolute error is not nearly as good as the 0.77s that we've been seeing. J48 graph, which is next, I can tell you uses doesn't like numeric classifications. M5P. Very fast. Results look similar to the linear regression. My guess is that's what it's really using. Random forest, which is one of my favorites. It's a little slow. This one takes just about 40 seconds to run. Excellent correlation coefficient, but mean absolute error is not all that great at 0.99. It's nephew or cousin here, random tree, just as fast, but the mean absolute error is worse. And last we get to choose from is REP tree. You run it, great correlation coefficient, but the mean absolute error is still not as good as the 0.77s that we saw. Nice thing about the trees, they give you a tree representation of how it does the calculation, and if you want, you can actually pull these trees out and do your own calculations likewise. Okay, now that's done, and let's take a look at how the top 10 performed by the mean squared error. All of these top 10, and most of the classifiers returned a correlation coefficient greater than 0.99, so we'll just look at the mean squared error. The winner is SMO reg or SMO regression with the value of 0.7691. Of interest is how linear regression and simple linear regression are almost alike, and linear regression, M5 rules, and M5P are similar. Looking at the output for M5P and M5 rules, that produced the exact same results. Text was exactly the same, so I have a sneaky suspicion that these two are actually the same classifier or Java function. Also wanted to note this is just a one-day look ahead, and the title of the video is has the word trend in it, so eventually we will take this out to 5 and maybe 10 days. In the next video we're going to change the result. We won't use a numeric result, we're just going to use a by cell indicator. The output from the classifiers will be different since we're not using a numeric classification. Until then, press the like button if you like what you see.